done with Unit 5, and I've got Unit 6 on there. As you can see, this is kind of a monster unit, okay? It's going to take us all the way to the end of the semester. So don't scroll it. Don't get overwhelmed, okay? Don't be mad, but we do have to keep learning. Even Friday before Thanksgiving break, we will have a lesson. It's not that bad, but we do have to keep going. So, if you're not going to be here, you're going to be getting an email from me with a video on how to do it, okay? The stuff we're learning this week, I promise we're going to keep practicing it over the next couple of weeks. You will be perfectly fine as far as remembering the stuff by the tests. But again, we just don't have a lot of wiggle room in Algebra 1 since we do have that STAR test. But everything we're doing in this unit is about systems of equations. Daniel, please sit up with me, okay? Systems of equations. It is a lot of stuff that we've done through the beginning of the year. However, it's times 2 because the system is going to have 2 equations. It's going to have 2 variables, okay? What we're going to focus on today is strictly just writing systems from word problems. So like I said, you're not going to need a calculator because we're not finding any answers. We're just writing equations. We're going to do a little bit of inequalities and being able to be given a scenario and write it mathematically, okay? We're translating it into math language. It is kind of boring, okay? It is word problems, and some people just hate those. So we're going to break it up. We got a little, we'll get the whiteboards out, do a little slideshow thing at the end for our practice, and then you should have no homework if we can get through everything, okay? So hang with me, all right? But that is the plan for today. All right, let's go to page 2. We are going to start on page 2. These are just going to be, page 2 is not a system. Okay, we're going to be writing one equation or one inequality just to get our brains warmed up with this, kind of see how it works, and then we're going to jump into 2 for our last page of notes, okay? So on page 2, on this first guide, looks like mine does, we're going to be writing equations and inequalities in standard form, okay? Our standard form of our linear equations, we have already seen those. They look like this. AX plus BY equals C. Okay, you've got your variables. Your X and Y are your variables. They're on the left-hand side. Again, we can also sub this equal sign with one of these guys, and we're going to talk about the difference and keywords that tell us when to use an equals and when to use an inequality. But A, B, and C will be numbers, okay? X will be a variable, Y will be a variable. Now, this is the first thing when you see these situations, is you got to figure out what are your variables. What is the story talking about? There's going to be 2 things that they're talking about, and we need to make sure we label those, okay? And then we'll have our equations, and we'll go from there, okay? So everything we're going to do on this page, there's just going to be one equation or inequality. Remember, these are our inequality signs. What is this sign, this first sign? Less than, because it looks like a sideways what? Page 2. Less than symbol, okay? So the next one is a greater than. We've talked about these before. We have graphed these. We will graph these again next class with the shading and all that stuff, so that's not going away. What makes the next one different with the line under it?
Less than equal to.
Less than or equal to. And the last one is greater than or equal to. Equal to. Okay? A lot of times, the questions that I've seen that kind of cover this page on the STAR test, they're really not too bad. But again, it's getting your brain warmed up, because if we can do it with one equation or inequality, then going to 2 is not going to be too much of a jump. All right? So let's talk about number 1. Mr. Wilson has 24 coins in his pocket. The coins are just nickels and quarters. Those are 2 types of coins. Write the equation in standard form that represents the scenario. So what do we have? What 2 things do we have?
Nickels and quarters.
Okay, so let's let in. What was in the problem? The 2 types of coins. N is going to be the number of nickels that he has. And you can use whatever variables you want. Okay. I don't like O's because those look like zeros. T's, if you're going to use a T, it needs to be a capital T, but we'll talk about that later. And then Q is going to be the number of quarters. Okay, so that's kind of the first step is you got to figure out, what am I talking about? What are my variables going to be? What are my unknowns? Okay? All right, so it says he has a total of 24 coins. Now you get a total by adding up everything you got. So what do we got? What does he got? 24 coins. So how did I get a total of 24? How do I equal 24? I add up the N plus Q. Done. That's all it is. Okay? Not yet. Not today. That's a post-Thanksgiving problem. Okay? So, coins equals total coins. All right? Now, let's look at Mr. Wilson in number 2. We kind of got a different keyword here. Mr. Wilson is going to buy pies for Thanksgiving from H-E-B for his family. For a pumpkin pie, it costs $8. For a pecan pie, it costs $9.50. He must spend less than $57. So is this going to be an equation? Am I going to have an equal sign in there?
Nope.
No, because of what words? Less than. Okay, so I'm going to use one of the signs above. One of those signs there. Now we'll get there. Write an inequality to represent the scenario. Okay, what are our variables? What are the two things he's shopping for? Pumpkin pie and pecan pie. Okay, both those start with P. Let's use, I'm going to kind of write in the problem for space. Let's use X for pumpkin pie and Y for pecan pie. Okay, so if they start with the same letter, you can always go back to X and Y. Okay? Now, we're not given he wants to buy this many pies. We are given what kind of value? What's in front of that 57? Dollar sign. So we need to include dollar signs in our inequality. So how much does a pumpkin pie cost? So $8 per pumpkin pies. See what I did there? Okay. What's going to be next? What else is going to total up for us? Well, I'm buying something else. Plus, what you got, Daniel? $9.50 what? Y. All right, that's our total money. We want that money to be what? Less than how much? 57. So do you see how it's a little bit different than an equation? Okay, you just use one of those signs. Well, it depends on how many you buy.
What's less than 57?
Yeah.
We don't know how many X's.
We don't know.
We don't know how many.
That's what's weird about this is you don't know. And that's why they're variables and they stay variables. We're not able to actually solve this. We need more information. Okay? All right. You guys try 3 and 4.
If you can do number 3 and 4.
Let's talk about 3. Senior class wants to go to New York City for their senior trip. They rented and filled 1 van and 6 buses with 372 students. Each van and each bus carried the same number of students. Write the equation. There's kind of a giveaway. What symbol is going to be in this? An equal sign. Okay, what are our variables? What do we have? We have a van and we have a bus. Okay, so you want to use V and B? Or did y'all use X and Y? Okay, does it matter? Okay, so V is going to represent how many kids are on the van. B is going to be how many kids are on the bus. So how do you write your equation? 1V plus 6B equals 372. Okay, do you have to put the 1 in front of the V? No. Is it okay if you do? Yeah. Okay. All right. Jackson needs to score at least 82 points on his test to pass the class. All even questions are worth 4 points and odd questions are worth 3 points. Okay, we need to write an inequality. Why do we need to write an inequality? At least, okay? So hang on, let's reason through this. So what 2 types of questions are on his test? Even questions, which are worth 4, and odd, which are worth 3. Points. What variables should we use for even? Variables. I don't like O. Can I use X and Y here? Because what does O look like?
0.
A 0. So I don't like that. Okay, so I went X and Y. Okay? Now, I'm going to underline something here. What did I underline? So when we get to the next page and we're doing 2, are you good?
Yep.
We're doing 2 equations and two equations. We've got to keep our units consistent. So if I'm talking about points, then I need to use all the numbers that represent point values. Okay? So I'm trying to score how many points total? Jackson's trying to score how many points? 82. I'm going to put that at the end. At least 82. I'm going to wait on the symbol because I kind of got to think about what it needs to be. Now, how's he going to get to a total of 82? Well, he's going to add up all the points that he got on the 2 types of questions. Jahan, how much are the even questions worth? How many points? So I'm going to put 4, and then I'm going to put that type of problem. 4 times x. So 4 times however many evens. Okay? Heidi, what's going to be next? What else am I adding?
Plus 3y.
3 per how many odds I have? I don't know. This is going to represent, look at what I'm circling. This represents his grade. Ethan, what do we need his grade to be?
At least 82.
At least 82. So does the grade need to be greater than 82, or does the grade need to be less than 82? Needs to be greater than or equal to. So I think this one is a little bit tricky because when people see at least, they want to say less than. But the way that it's usually set up, it has your variables on the left. And so think about it, 4x plus 3y is my grade. I need my grade to be greater than or equal to 82. Okay? One second here. Let's hang on to 5 and 6 until next class. Okay, we're going to come back to those for next class. We'll probably make them part of the warm-up. But let's flip over to page 3. We're going to write down some key words, and then we're going to jump into our examples. Okay? So here's kind of our steps. It seems like a lot of steps. It's really, in theory, it's not that many, but we kind of really broke it down. The first thing you need to do is you've got to identify your variables and what they represent. I'm going to be more like specific than I did on this because there's not a lot of room on page 2. But we're really going to be talking about, X stands for the number of tacos. And Y stands for the number of enchiladas, that type of thing. Okay? And so that's kind of step 1 and 2. I don't really know why those are 2 different. Then we're going to be writing 2 equations. So this is where it's going to get a little more challenging. We got to figure out what stuff goes together. And that's where looking at units is going to be real important. Okay? We're going to highlight or box keywords, 1 equation at a time. Okay? So I'm going to color code. I'm going to use 2 different colors. And then we're going to actually write our equations. But before we do that, we need to go over some math language words. Because again, we're really it's like we're in foreign language today. We're translating. We're translating from a word problem to a math equation. So some words that could mean add. If you see them in a word problem, some words that mean you need to do an addition would be more than. Okay, that's a pretty big one. More than means that I'm going to be using an adding operation. They might actually write it out, plus, like a plus this. Sometimes it'll say and the number of hot dogs and hamburgers. That would mean to add. And then another one would mean I'm talking about a total. Anytime we're talking about total, which is quite often, we're going to be adding up our variables there. So these are kind of some key words we want to watch out for. If we see those are saying, hey, operation is going to be addition. Okay? We also have operation that could be subtraction. All right? So some of those words would be, well, if more than means that we're going to be adding, what do you think we would use here? Less than means we could be subtracting. Plus means adding. What means subtracting? Minus means you're going to use subtraction. Another one could be fewer. You know, you're ordering 5 fewer hot dogs than hamburgers. That means you need to do a subtraction. Shorter, if you're talking about like perimeter and stuff. Those are all kind of indicators that it's going to be a subtraction problem. All right. Multiply, really the big key word here, meaning like, hey, I'm going to have to multiply as if it says times. Okay. Or it could say twice as many. I'm going to put just ... with that because it also could say 3 times as many, 4 times. We're not going to write all those, okay? But that means we're going to be doing a multiplication. I don't think you're going to see a whole lot of division, but we'll go ahead and put that on there. Half as many. And again, I'm going to ... with those. A third, a fourth, like just saying fractions of that, but I don't really think we'll see much of that. Words that mean equals, this is a big one, okay? Is, so if it says like the length is, that means L equals, okay? Is or even was, if it's like talking about a story past tense, was means you would use equals. They might actually say equals in there. And then also we need to talk about our money values because we are going to see problems kind of like the Mr. Wilson one. And we want to know how much coins are worth, okay, in terms of a dollar. So how much is a penny worth? 1 cent. Now how do I write that in terms of a dollar? 0.01. 0.01. I don't put the 0 in front, but that's okay too. 0.01 is a penny. What about a nickel? 0.05. Not 0.5. That's the one that people mess up. They want to put 0.5. It's 0.05. A dime, 0.10. I always put that 10 because it's, to me, it's like 10 cents. You don't have to put the 10, but I think it's helpful. And then a quarter is 0.25, 25 cents. Okay? So when we see problems like that, we're probably going to have some money values. And then the last thing on our little help sheet is going to be some formulas. And we put these on here. I will tell you the one that we use the most is perimeter of a rectangle. Right here, I'm going to star this one. But I saw these two on a star question last year, so I thought it would be worth going over. But what's the one we're going to use the most? What's a perimeter of a rectangle? You don't know how to get the perimeter of a rectangle? How do you get perimeter of a shape? Add up all the sides. All right, so here's my rectangle right here. How many lengths do I have?
2.
How many widths do I have? 2. So I'm adding my 2 lengths and my 2 widths, and that gives me my perimeter. Okay? Which really, if we see a perimeter problem, this is what we need to use. Because we'll know what the perimeter is. They'll tell us what that actual number is. What about the area? How do you find an area of a rectangle? U times what? Times the length and the length times width is your area. What about area of a triangle?
Like times width times height.
That's volume.
So when you think about a triangle, I've got a rectangle. I cut a rectangle diagonally. What shape does it make?
Triangle.
It makes a triangle.
Yeah.
So if I cut it in half,
A equals 1/2 BH.
yeah, 1/2.
BH or 1/2 length times width.
Means the same thing, right?
Okay.
And I like to do base times height divided by 2.
Or base times
So
height divided by 2.
That's how I like mine.
You're the geometry brain in here,
Yep,
so
yep. So you'll
help
see
me
a lot
out.
of this next year. So
Yeah.
If you know this now, that would be great.
And again, I was flipping through last year's star. Well, not flipping because it's on the computer. I was clicking through last year's star. And they did give them a question that said something about the area of a triangle and the area of a rectangle. And y'all, those were not on the formula charts. So can you imagine I was a little bit mad about that? I was mad
It's
about that.
interesting, they didn't put it on the formula chart.
Nope. They didn't give it to him either. Mean. Sometimes they are mean. Okay? All right. So let's pick up. This is the last page we're going to do. Again, I told y'all this is pretty boring, and I'm sorry. I thank you for paying attention. We're going to knock out these examples here. And here's the thing with the word problems. There are so many different types that the only way we're going to really get better at them is just practicing all the different types. Okay? Because there's 1,000,001 ways I can give you a word problem. Some of them are like real fast. So I'm going to kind of skip around and do these in a certain order of what I think. We'll start with like some of the quicker ones. Give ourselves some confidence. And then we'll try some of the more challenging ones. And then I'll give you some that are like, hey, these are really important. Make sure we need to look at these again, okay? But we'll knock a couple out, take a little break, and then work on a little bit more, okay? We're actually going to start with number 2. Let's start with number 2, okay? And again, remember the flow. We've got to figure out what our variables are and what they represent. We've got to figure out what types of equations we're going to write. And I kind of label. I start like giving you a little more information. But we've got to sift through the information. And we're trying to get 2 different equations. All right, it's not just one. We're going to 2. So let's read the story for number 2. Number 1 is probably going to be the last one that we do because it's a doozy. Okay? All right, Michael bought 3 enchiladas and 2 tacos, and how much did he spend? $2.60. We got to find this taco stand because this is cheap. Okay, Jeff, I think that should say bought 2 enchiladas and 3 tacos for $3.04. Write a system of equations that represents the situation. So first thing, what are our variables? I gave you a hint. I told you we're going to use E and we're going to use T as our variables. So what is E going to represent? Okay, now it's not just the number of enchiladas because I know how many enchiladas they bought. What is this going to be? What do we not know? What are we looking for?
The overall money.
The cost of the enchiladas. You did? I'm sorry, I didn't hear you. Price or cost of enchiladas. I'm going to have to abbreviate here. Okay, so this one's kind of different. And then T would represent what?
Tortillas.
No. Cost of tacos. Okay, now we're not finding this right now. We're just setting up equations for it. Okay, so those are the things we're comparing. We got a cost of buying enchiladas, a cost of buying tacos. But how many people are at the taco stand? 2 of them. Michael's at the taco stand, and he's got a total. Jeff's at the taco stand. He's got a total. So I'm going to have an equation to talk about Michael and an equation to talk about Jeff. Okay? Let's talk about Michael. I'm going to help you with Michael, and then you're going to do Jeff on your own. All right? What did Michael buy?
2 tacos.
2 tacos and 3 enchiladas. And how much did he spend? $2.60. So and means we're going to do, where did and lie on our list? Where was and? Addition. So we need to add up Michael's total for buying 3 enchiladas. So at some price times 3 plus, because it says and, so we're combining how many tacos? 2. Use a capital T. And what was his total? What was Michael's total? $2.60. So remember, that's what I'm saying. This isn't realistic. This must have been pre-inflation. Pre-inflation, okay? Now it would be like $12.60 or more, okay? All right, so there's Michael. Now, we still are talking about costs. We're still talking about money because E is a money value, T is a money value. So money, money, money. All right, that's Michael's. So I'm putting all of this together, and now I need to put Jeff's together. You do Jeff's.
Yes, I will do.
This is one that I kind of call like a straightforward one because it's like this guy and this guy. And that's all you have to do. Okay, I think it's a little bit easier because it's just straightforward. So what is Jeff's equation? Nick, you got it?
2e
2e
plus 3t
plus 3t equals
3
$3.04. So that's Jeff's money. We're done. Done with that. We're not solving it, not yet. Okay? Let's try 4. All right, we're going to try to do 2 more, and then we'll take a brain break. Okay, let's try 4.
2 more after this, or this is 1?
This is 1 of 2. So we're going to do 2 more. The width of a rectangle is 3 times the length. The perimeter of that rectangle is 88 inches. Write a system of equations to represent the situation. So what are our variables?
No idea.
The width and the length. Okay? So it's talking about width and it's talking about length here. So let's use W is width and L is the length. Just FYI, I'm going to star this. Anytime you see the word perimeter, anytime, these will be your variables, length and width, okay? And then also, when you see a perimeter problem, you are going to have an equation that talks about the perimeter, okay? So right here in this blank, I want you to write perimeter. This is kind of the giveaway. Anytime you see that word perimeter, you will have an equation talking about the perimeter. Now, don't be tricked. Perimeter is not a variable because we know the perimeter. What is the perimeter? 88 inches. Okay? So, perimeter is equal to 88. And what is our formula for perimeter? We wrote this on the other page. Flip it back. What was our formula for perimeter? I told you to put star by it. I told you you're going to see it. 2L plus 2W. So that's going to be like a giveaway. That's a giveaway equation. 2L plus 2W, and it equals whatever's in the problem. It will be given to you in the problem if it's talking about perimeter of a rectangle. Okay? So that's there's usually an easy equation. And this one would be the easy equation, my perimeter equation. Now, what's the other piece of information that we need to write about? What?
Area.
No, it doesn't say anything about area. What else does it say? What does the first sentence say? The width is 3 times the length. We need to write a sentence about that. Okay? So what are we talking about? Watch how I look at this. The what is. What does it say? The width. So I'm talking about width is means equals 3 times length. What does times mean? You're going to do what operation? So 3L. How'd I get to where? For perimeter? That is my perimeter formula. If I have a rectangle, to get to that perimeter of 88, I have to add my 2 lengths and my 2 widths. So every single time you see perimeter, you will do this formula. Okay?
Yes.
Every single time you see perimeter, you will do this formula. And then this equation, I don't even know what to call that equation, so I'm not going to worry about that. This goes width is 3 times length. Okay? All right, so I want you to look at how I did 4, and I want you to do number 3. Okay? Try number 3. This will be the last one that we do before our break. Your variables on number 3. Length and width. Okay? Width here. All right, so we have a perimeter problem. Now, this doesn't outright say perimeter, but anytime it's talking about, she wants to enclose her rectangular garden. So she wants to put a fence around her rectangular yard. A picture frame. Those are all going to be kind of perimeter things, okay? So, Johan, what's our formula for our perimeter? 2L plus 2W. And in this story, What is that equal to? 32. Now, something like, again, you've got two equations. You have to be able to know when you use the information and when you're done with it. I'm done with 32. I'm marking it out. Bye-bye. No more 32. Okay? That takes care of the first sentence. The next sentence, Daniel, help me with this one. What does it say? She wants
The length to be 3 times the width.
length to be 3 times width. How do you write that in math language? What are we talking about?
L equals 3W.
Length to be is equals 3 times means you multiply width by
W. What? 3.
by 3. You wrote it right. You said it right. I'm just trying to break it down a little bit more. And so there's my situation there. Well, and this, you thought it was what? Oh, is that what you had on there? That was my bad if I told you that was right. So, do you see which one we're talking about first? She wants the length to be. Usually which one comes first is the one that has to be on the other side of the equal sign. The length needs to be that much. Okay, that was my bad. All right, let's take a 2-minute brain break, and then we're going to finish up these 3 more problems to do. Then we're going to do a little whiteboard practice. Close your Chromebooks.
2 minutes.
Oh, that was definitely more than 2 minutes. I want you to try number 6 on your own. Try number 6 on your own. Okay, and then we'll knock out the last 2 together. So read through number 6. It's kind of similar to another one that we've done if you want to kind of look at your notes and see how we structure it. And then we'll do the last 2. Okay, so this one was kind of like what number? What was number 6 kind of like? 4. 4?
2.
2. It's kind of like 2. Okay? So we've got 2 people, 2 families at the movies, and you've got a situation. You've got a total that Anna's family spent and a total that Claire's family spent. Now, those are not the variables. Those are how we're going to set up our equations. One for Anna, one for Claire. But what are our variables? What are we shopping for? What are we buying? Popcorn and drinks. So those are what your variables are. And this, again, is the price of them. Because we know how many they bought. So this is going to represent the price or the cost or the money value, whatever. You can kind of write it a couple different ways. So I use P and D. If you use X and Y, it doesn't matter what variables you use. You just need to tell me what variables you are using. Okay? Now, I wrote my first equation about Anna because the first Anna was talked about first. But the order of the equations, again, that doesn't matter either. So what equation represents Anna's spending?
I put 3P plus 2D equals
3P plus 2D equals 21 because she bought 3 popcorns and 2 drinks. She spent $21. Okay? Mohammed, can you tell me Claire's? Okay, I used D for drinks, but yeah. And then what was that equal to? 22. Okay? Now, we talked about this doesn't really make sense because Anna bought more stuff, so she should have spent more, but we'll expect that Anna had a buy one, get one free or something. Okay? But that's how you would set it up. Again, it's kind of one of those straightforward. Now, I also want to emphasize here that your actual answer is just the equations. How I've been kind of labeling like, oh, this is Anna and this is Claire. That's not like part of your answer. That's just to help you kind of like, again, reason through it. So your equations, and it doesn't really matter which one you put as 1 or 2. It just matters that they are matching. Okay? All right, the last 2 we're going to do together are 5 and 1. Okay? And these are, I'm boxing these so we know what our answers are. 5 and 1, I think, are definitely more thinker problems, but we can do it. We've got this, okay? So let's start with 5, okay? A science test has 25 problems. Some test questions are worth 2 points. Some test questions are worth 3 points. The test is worth 60 points total. Okay, so I've got a couple pieces of information. I have a total of 25 problems. And my test is worth a total of 60 what? Points, okay? Now, I have 2 types of questions on there. I have 2-point questions and I have 3-point questions. So my variables are going to be about those 2 types of questions. So let's call them X and Y. Okay? We'll get back to the units in a minute. So let's let X represent the number of 2-point questions. So then what would Y represent? Number of 3-point questions. Okay, those are the two things I'm comparing. How many 2-pointers, how many 3-pointers? Okay, now I need to actually write my equations. I need to sift through that information. This is a good problem to know how to do. I might put a star by this. Okay. So let's talk about the first thing I circled. A test has 25 problems. What are the two types of problems that we have on the test?
2-point.
2-point and 3 points. So if I want to get to 25 problems, what do I do? How do I get that there's a total, hint, hint. What does a total mean? Add what? 2-point problems, which are X, and 3-point problems, which are Y. Okay, so look at the units here. This is the number of problems plus the number of problems equals the total problems. You see how those are the same unit? Nothing about points. I'm not talking about points here. I'm just talking about the number. Add up all the 2-pointers, add up all the 3-pointers. That's got to equal 25. Now, the other information that I circled was what? 60 what? Points. Now I need an equation about points. Well, how many total points do I have on the test? 60. And I get a total by adding up. Now, X and Y represent problems, so I need to put the value, the point value. How many points are a 2-pointer worth? So 2X. How many points is a 3-point question worth? 3Y. So make sure you put those variables. So I want you to look at this. I want you to look at my setup. Problems plus problems equals problems. And the other one is points plus points equals points. That's how I set it up. I got to keep that consistent. I have to pay attention to my units. Okay?
You're going to hear us say that all through this unit. Money plus money equals money. Problem plus problem equals total problems. Okay? Points plus points equals points. So you want to try to keep that consistent. Okay?
Yeah. I think the one we see a lot is like tickets. I feel like I always say tickets, money.
Yep.
Okay? But this is kind of like that. It's kind of the same type of setup. All right, last one. And then we're going to get the whiteboards out and do some practice with partners. Moving around a little bit on this Wednesday morning. Hey, Nick, this problem's about you. Okay? You have a pocket full of coins that total $6.65. He has dimes and quarters. So what's your variables going to be? Dimes and quarters. Let's go ahead and fill that out. So D stands for, we already know the money value, so this is going to be the number of dimes. Q will be the number of quarters. Okay, so he's got those two types of coins, and he's got a total of $6.65. Let's go ahead and talk about, well, we'll finish reading it. The number of dimes is 5 more than 3 times the number of quarters. Whew, that's going to be tough. Write the system that represents this situation. Okay, so when I look at my units here, I've got a money value unit. Let's go ahead and just talk about that equation. Money value, money equation. He has a total of $6.65. So what do I need to put at the end of my money equation? Equals $6.65. Now it's money. So I need to talk about the money value, which we wrote on the other page right before, of these two types of coins. What's the money value of a dime? 0.10. What's the money value of a, what's the other one we got? Quarter? Okay, so when I set that up, I need to do 0.10 times the number of dimes. You have to have that variable there. So 0.10 times D. What else am I adding? 25 cents per quarter. So 0.10 D plus 0.25 Q equals 665. Here it is. Money, money, money. You see it? Money, money, money. If I didn't have that 0.10 and that 0.25, I'd have coins, coins, money. That doesn't make sense. It's got to be money, money, money. We okay with that? All right, this next equation is kind of tricky, so let's talk through it. It's going to go with this sentence. The number of dimes is. All right. What is the number of dimes? How are we translating that? Number of dimes is what? No, it's not. We don't know the number. The number of dimes is our variable D. We're talking about dimes. Is means equals. Dimes equals. So y'all see how I just read that? Dimes is. Okay? 5 more than 3 times the number of quarters. Okay? More than means what operation? Adding. So I'm going to leave a little space after the equals. I'm going to put a plus sign right there because I know I'm going to be adding. Now, more than and less than. You did this to me.
It's the than rule. So when you
The
see
than
the
rule.
than,
Are you listening?
there's a rule that follows it. That's why we call it the than rule. So when you see than, you're actually going to do what comes after than first. So what comes after than? 3 times the number of quarters. So that's what's going to go first.
How do you write that?
3Q.
3Q.
And then you go back to the beginning, which says what? 5 more than. So the more than is the plus, and then you put 5.
So it's kind of like a switch. You
So
switch it.
On this problem, it wouldn't matter how you write it, because if I add the 3 plus the 5, I'm going to get the same thing if I add 5 plus the 3, right? But whenever we get to subtraction, that's when it really comes into play that you put it correctly.
Yeah. So you've got to
Think about
be
the than rule.
careful. It's a switch. Switch it around, okay? And that, honestly, I think this is the hardest problem on the whole one. Because it's a lot of, again, sifting through information. So we will continue to practice word problems every single day, okay? Because eventually we're going to get to solving them. But we got to make sure we remember how to set them up, remember those keywords, those type of things here. So I would say keep these out. Or I'm going to at least kind of keep this. And in a minute, we're going to do a little whiteboard activity. And this will serve as our homework, okay? So here's the rules. This is from a different teacher, so ignore the name that it's not mine. But, we can go with it. We're going to partner up, and you're going to be moving. You're going to be getting a different partner each time. We're going to be giving a word problem. And you're going to have 2 minutes to write down the system. And then we'll turn and share and see if we got them right. Okay? So that's what we're about to do.